We are a mobility team. I'm Nishant Agrawal. He's my teammate. You guys will be presenting you what we did for the whole semester, the project SIP Mobility. Alright, so here's a short introduction to our project. SIP Mobility refers to creating a small GSM network through which you can make different calls to your fellow guys in the same network. We use different devices for this. Our major goal was to create a 2G and a 3G network so that the calls flows through 2G and 3G networks, and switching from that to a 3G network for making a video calls within an organization, or let's say IIT. So we intend to achieve this by using an OpenBTS. It's an open source software. It is available on the internet, and Asterisk has the IPPBX. Since our project has different goals, we intend to provide 5 milestones, I'm sorry. 5 milestones to it. Our first milestone was to install OpenBTS, which is the main source of our project. Our second milestone, we kept it as configuring the Asterisk, which is the part of OpenBTS, which comes ready with the OpenBTS whenever you download or whenever you configure the OpenBTS application. A third milestone was to install the USRP. That's our base station device. It comes with the work for this is to provide the signal whenever a user agent 1 is calling to user agent 2. It provides a signal so that your call can flow through the bed. And we need 2 softwares for this. The first one is the GNU Radio, which is available as an open source. And the second one is USD. It's the Universal Hardware Driver, which is required to install the USRP so that the USRP works. And our fourth milestone was to configure OpenBTS 4.0 that works with 2G, and the OpenBTS UMTS that works with the 3G network. And our fifth milestone, we kept as taking our traces on the Wireshark so that we get to know what is happening on the network. So this is our USRP, Universal Software Radio Peripheral. It is series N200. It provides the radio signal to the mobile devices so that the call flows from one user agent to the other user agent through the OpenBTS and the Asterisk. So it was initially designed and put it in the market by ETIS Research and its parent company National Instrument. It has a high dynamic range processing capability. So basically USRP is a hardware and transmit-receive data device. It helps you in transmitting the data between the mobile devices or the smartphones if you are using. This is our structure, how the USRP is connected to the system and how does it work. Basically a USRP includes an antenna which provides a radio signal. It includes an Ethernet port which goes directly to your LAN cable, through the LAN cable to your system, and it has one power supply port so that it connects. The 2 important software which I was talking about to run the USRP are GNU Radio and the UHD. The GNU Radio is the device which it acts as a toolkit. It acts as a software toolkit which works for the USRP, and UHD is the hardware driver for the USRP. I'll hand over from here to my fellow mate Adesola.
Well, this is a physical architecture of what our project in the lab was. We had a computer running on Ubuntu with the Asterisk in the OpenBTS software and the USRP, which provided the signal for our device. Okay. No.
No, on your shirt. Point it up.
It has to come up. Yeah. This one. Thanks. Thanks. Yes, so the USRP provides signal to our devices, to our mobile devices. Well, so OpenBTS allows you to make calls on 2 mobile devices. Yes, but then how? How does it do that? There are other components in the OpenBTS that allows you to do that. We have what is called the SIP or serve. It's a proxy, registration proxy that goes into the OpenBTS, or sorry, the Asterisk to verify that the user is registered on the network, which is supposed to be our OpenBTS network. We also have something called the subscriber registry, which is the database of all the user agents on the network. This process has to take place before you can make calls on an OpenBTS. And then the SMQ is also sort of a short message system in which if you're not registered on the network, you have to send a text message, and then it'll register you on the network, and then you'll be able to make calls. Well, this is a logical architecture of what OpenBTS is supposed to be outside. Let's say you have one in your office. The USRP gives you signal, and then let's say you have 2 devices. So it gives you signal on your devices, and then both user agents should be registered in the Asterisk, and then you can make your calls between both of them. Okay, this is how it registers user agents on the OpenBTS network, for instance, let's say. So you try to make a call. It goes into the database to verify, is this person on our network? If it checks and then it sees, no, you're not on the network, Asterisk will send it a message saying, this person is not, this person's mobile number is not registered to this network. It will reject your call, and then you would have to send an SMS, just like I said earlier. We intend to be able to allow our project to support other testbeds in the future. That's the NG911, voice over IIT, and the SIP benchmark. We also intend to do a 3G, that's the video and voice call, over the next few weeks, because we weren't able to do video calls. But in the next few weeks, we intend to be able to make video calls on the the OpenBTS project. Thank you, and we'll entertain your questions now.
Any plans for 4G LTE?
Yes, we have a software called OpenBTS UMTS, which supports 4G. Nobody has actually built OpenBTS that works on 4G, but myself and Nishan, we're really planning to do this within the next few weeks.
It's still not out in the market with the 4G and LTE. So we are ready with the software, but we are about to make the calls on the LTE. We have still not done that, but we are sure we'll be doing it in December.
Okay.
In order to go to 4G, you need to have the hardware box upgrade too. Is that true?
No, we don't.
Really?
No.
You use the same?
Same thing. Same USRP. Yes.
Just a one-time investment.
Okay.
What would be the major challenge for supporting video calls? What's the difference between supporting voice calls and video?
Let me think about that. The challenge between supporting video calls.
Difference there?
I didn't get you?
I mean, what's the difference between supporting voice calls as you're doing right now, supporting video calls?
Okay, with voice calls, it's just easy. You just register your clients on the Asterisk, and then you can make calls just like every other testbed. But with video, you have to integrate the software. You have to integrate OpenBTS UMTS. Everybody's working with OpenBTS 2.0. That's easy. But
For GSM.
exactly. But with UMTS, it's another level. You have to take it. You have to work nights. We've been trying to integrate it, but it hasn't worked yet. Yeah. Any other questions?
Thank you.
Thank you.